All right, so I just want to review the mole map with you. If you remember, moles is always in the center. We have to always convert to moles before we get to anything else. Anytime I'm going into moles, I'm going to divide. Okay? Anytime I'm coming out of moles, I'm going to multiply. So here, this is your particles. And my conversion factor is 6.02 times 10 to the 23rd. This is volume. So my conversion is 22.4 liters. And this is mass. And it's going to be molar mass for my conversion. So this one is the one that constantly changes because one, we don't know, every compound has a different mass. All right, so first off, let's look at this problem. So it says, how many moles are in 7 grams of sodium hydroxide? So I am in grams. So the very first thing you should always do is write down what you're given, 7 grams. And you've got to know this formula. So sodium and hydroxide, this is a +1, that's a -1. So NaOH is be my formula. So if I'm trying to get out of grams, 1 mole equals the amount of grams of sodium hydroxide. And sodium hydroxide is going to be, the mass is 23 plus 16 plus 1. And I'm doing this as a rounded version just to be quick. Now, this is going to give me, so really what you're doing, is you're simply taking 7 grams and dividing it by 40, which is going to give you 0.175 moles. All right, so here's what we've done. We've gotten rid of grams. This is why I always do unit conversions. And I set up, this is what's called a conversion factor here, because it lets me know that 1 mole of sodium hydroxide equals 40 grams. All right, here's the next problem. How many grams are in 2.56 moles of aluminum chloride? So first of all, you got to write your formula. So aluminum has a charge of +3. Chlorine has a charge of -1. So remember, this 3 is going to go out there. So AlCl3. All right, so I start with what I'm given, 2.56 moles of AlCl3. Okay. This time I'm in moles and I need to go to grams. So I'm going to multiply. So 1 mole is the same thing as the mass of aluminum chloride. So aluminum chloride is 26.98 plus 35.45 times 3. So 133.33 grams. Notice that moles cancel, so I'm taking this and multiplying by this, which is going to give me 341.33 grams of aluminum chloride. Okay? All right, let's look at another one. Let's look at liters. So I'm going to go back and look at our mole map. So notice that I can't go from mass to volume. I have to go into moles before I go to volume, or if I'm in volume, I've got to go into moles before I get to mass. So this is going to be like a 2-step problem. All right, so you got to remember, if I'm going into moles, I divide. If I'm coming out of moles, I multiply. So how many liters are in 65 grams of dinitrogen dioxide? So first, write your formula. Di means 2, so N2, O2. All right. So I know I have 65 grams of this. I got to first get out of grams. So 1 mole equals, so 14 times 2 plus 32. Oops. So this is 60 grams. Notice grams are gone. All right. I'm in moles. All right. I need to get to liters. So 1 mole equals 22.4 liters. So notice that moles are gone. So I take the 65 and I divide it by the 60. And then I multiply it by 22.4. And I'm going to get 24.27 liters of N2O2. So notice that this was a two-step problem. All right, here's another one. I'm going to make this one up. Let's say I've got 3.5 liters of water, and I want to know how many grams, or what is the mass. That's another, okay? So I start off, write down what you've got, 3.5 liters. To get out of liters, 1 mole equals 22.5 liters. This is the conversion factors. Notice how liters are gone. Times, now I need to get to grams. So 18 grams of water equals 1 mole. Notice my mole's gone. So 3.5 divided by 22.4. That should be 4, not 5. Sorry. Okay, times the 18 gives me 2.81 grams of water. So that's how you do mole conversions, looking at moles and masses.